Hello Mindsetters, welcome to today's grade 11 math show. Today we have a special revision lesson on functions. We have selected highlights from lessons shown earlier in the year to help you with your revision. Please send us your questions and comments on Facebook on facebook.com/learnextra or on Twitter @learnextra so we can help you revise. Don't forget to download today's show notes on learn.mindset.co.za or click on the link on our Facebook page. Now it's time to get on with the revision.
Okay, then the first question we're going to look at is not really a question, but it's actually an investigation. We're going to sketch the graphs on the same system of axes, and then we're going to discuss the effects of P. But in order to do that, we're going to look at some points. And so I'm just going to draw a table of values on the side. So let's draw a table of values for -3, -2, -1, 0, 1, 2, and 3. And now we're going to work out what is x squared if this is x. So if x is -3, then x squared is going to be 9. If x is -2, then it's going to be 4. Then we're going to have -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. So that would give us this graph over here, y equals x squared. Now we're going to add on, let's just get this table here, and let's get some more y values, and let's get more of these in. So I just want to complete this table. Okay. Now, if we're looking at this graph over here, the x value that you've chosen, -3, you must add -2, which makes it -5. And if we square it, we get x minus 2 all squared. And so we get a 25. Then at -2 minus 2, we get -4, so we get 16. At -1 minus 2, we get -3 squared, which is 9. At 0, we get 4. At 1 minus 2, we get 1 minus 2, we get -1 squared, which is 1. Then we get 4 minus 2 is 2 squared, which is 16. Just double check this. This is 4. This is 1 minus 2 is -1 squared is 1. 2 minus 2 is 0. 0 squared is 0. And then 3 minus 2 is 1, and 1 squared is 1. So just a little table of values to help us plot the graph. And then this graph over here, we must add 2. So x plus 2, let's just see why this is curling here. Let's just get that there, plus 2 squared would be -3 plus 2 is -1 squared is 1. -2 plus 2 is 0. -1, 2 minus 1 is 1, so we'd get 1. And then we have the 0 plus 2 is 2, so that's 4. 2 plus 2 is 4, actually 1. 1 plus 2 is 3, so 3 squared is 9. And then we have 2 plus 2 is 4, so that's 16. And then we have 3 plus 2 is 5, and 5 squared is 25. So we're going to plot the green points, the yellow points, the blue points, and then we're going to just verify what is actually happening to that function, to that parent function, y equals x squared. So if I have, for example, my quadrant, I can see that all these y values that are in this table are all positive. So I'm just going to use quadrant 1 and 2. And if x is 0, then y is 0, so we can plot the green points. If x is 1, then y is 1. If x is 2, then it's 4, 3, 9. And we've got exactly the same pattern repeating on this side. And we can see that there's my green graph. The function x squared shows us that the y values are all positive. The function has got a line of symmetry, and the points are symmetrical about that y-axis. So they are equal, the same distance away from that y-axis. Now, if I look at x minus 2 squared, I'm getting, at -3, I'm getting 25. At -2, I'm getting 16. If I just go to my 0, at 2 I'm getting 0. So if I go to 2, I'm actually getting a 0. And then if I go to 3, I get a 1. And if I go to 1, I get a 1. And so forth. So I'm getting those points there. So if I plot these yellow points, this is very interesting, grade 11s, as you plot these points. Because whereas the y-axis was our line of symmetry for the green parabola, we now see that this yellow parabola does not have the y-axis as the axis of symmetry. And that is a deviation already from what you've discussed in grade 10 on the parabola. Whereas all your parabolae had the y-axis as the axis of symmetry, immediately after plotting that yellow graph, that y-axis is not the axis of symmetry. We can tell that straight away. Okay, but let's plot the blue one and see what happens to that one. At -2, we have a 0. So we have a -2 over here and a 0. And then on either side of that, we have a 1. And then at 0, we have a 4. Okay, so this graph is doing this. And on the side, it's doing that. Okay, so this is very interesting. Both the yellow and the blue graph show us that the axis of symmetry is not the y-axis. So something new is happening over here. And if we look at the equation of that parabola and the equation of this parabola, we will see that there's been a constant that's been added to that x value. And that effect of just adding that value is that you are saying, hang on, the 0 is not happening at 0 anymore. This 0 is happening at 2, and this 0 is happening at -2. So we can even see on the table that this 0 has shifted to the right, and this 0 has shifted to the left. So the position of the 0 has translated. And in other words, this y-axis is now here. That's really what we're saying. The 0 is now at this value, and the 0 is at that value. So in this yellow graph, we have the 0 at 2, and we have, on this blue graph, we have the 0 at -2. So if we now try and connect what is happening with the effect of p, remember we were looking at the equation y equals x minus p squared plus q. And at the moment, we're only looking at the effect of p. So I haven't added a q yet. We're just looking at the effect of p. And just a glance and an observation is that that axis of symmetry has shifted. The axis of symmetry has shifted in which direction? This one, it's moved to the right, and this one, it's moved to the left. So the axis of symmetry is no longer at 0. Okay, so let's try and connect. Let's try and connect with that. What is happening to this equation? And what is happening with this equation? What can you see? What can you tell me? Okay, very clear that if the graph will translate to the right, then p is the amount of units that it's translated to the right. And if it's translated to the left, then p is the amount of units that it's translated to the left. So we can make some deductions of the work that, or we can specify the deductions from the work that we've done. So I can actually generalize and say, if y equals x minus p squared, then I can take two types of p values because I've got p as 2 and I've got this p as -2. So if p is negative, then y equals x minus p translates, which way did it go? Remember, it's this graph here. Then that translates horizontally. How many units? P units to the right. However, if p is positive, then my y equals x minus p squared will translate horizontally p units to the right. And so the general formula for your parabola then is y equals x minus p squared plus q. And what we're really saying is that the equation y equals x minus 2 squared, let's just erase this for a second. We don't need this q at the moment. Let's just work with this one. We are saying that in this case, this is a case where p is positive. P is positive, whereas in this case over here, where y equals x minus negative 2 squared, this case is one where p is negative. So our formula is always written in the x minus p form, and x minus, that value will tell us what p is. So x minus, that means my p value is p. P is 2 in this case, so p is equal to 2, whereas in this case p is negative and p is equal to negative 2. So the formula must always be in the x minus format for you to be able to extract what your p-value is and for you to know which direction it will move in. So if p is 2, we're now getting 2 minus 2 is 0. So we're zeroing that value at 2. At which x value do we get the 0? That's really our question. And so this p-value will actually give us the axis of symmetry of that parabola will be x equals p. So if we just go back to the two graphs and we look at how this x equals minus 2 is actually the axis of symmetry, and how this x equals 2 is now the axis of symmetry. So come back to these graphs often to just indicate to you how those translations have happened. The x minus 2 connects with the yellow, and the x plus 2 connects with the blue. So that would be the effect of p and q. Sorry, just the effect of p. I think we'll take a break and we'll come back and do q.
I think it's time for a break now, so go do a few stretches, take a deep breath, but don't go too far because we'll be right back. Welcome back from the break. Remember, if you need to revise any other topics, you can get the notes and watch all the videos from the Learn Extra live shows on learn.mindset.co.za, or you can subscribe to our YouTube channel, youtube.com/mindsetlearn. You'll find that we've organized all the videos into shelves and playlists to make it easy for you to get what you want. Now it's time to get back to the revision.
Well, grade 11s, I've just done the most difficult translation, I think, to understand in functions, because you're going to find that that horizontal translation is going to be visible in all the other graphs that you're going to encounter, your hyperbolas, your exponentials, your sine graph, your cos graph, your trig graphs. So the movement along the x-axis is affected, or the translation on the x-axis is affected by that value that you're adding onto x. So you're going to see that evidence of that later on when we look at the hyperbola. For now, I want us to see what the effect of q is, and I don't think this is very difficult. I think this is the easy part of working with a function, and that is if I add 1 onto each of the graphs we sketched earlier, look what happens. For every y value that you have on the green graph, you're going to take it up by 1. So that value is going to go up by 1. So that value is going to go up by 1. So you're actually going to land up with a graph that has just gone up by 1 value. So the q affects a vertical translation. So it's a vertical translation. And if I do it to the blue graph, the same thing's going to happen. If I take that y value that I currently have and I add 1, my y value is 0 here. So if I add 1, it's going to go up 1. That value is going to go up 1. That value is going to go up 1. So everything's going to go up 1. So this graph is going to do that. So they have all been raised by 1 unit. Okay. So in fact, these y-intercepts will also go up by 1 value, but they're now hovering. And you can see that the turning point is now made up of, this is very important, turning point is made up of P's value, and the y value is the Q value. So what I've done is I'm now saying this is a positive quantity, but if I'm adding 1, everything is now going to be larger than 1. This parabola is not going to have values in here. It's not going to have these y values. The range for this parabola is affected by that Q value. In other words, we can say that the range of all these parabola that we've sketched starts at Q and it goes to infinity. So Q affects the range as well as the turning point. Okay, lovely. It's just a little constant that just affects that up and down movement. Okay, but now we're saying that my parabola, can you see how it's written? It's written in a unique way. It's written as x minus 2 all squared plus 1. It's written as x plus 2 all squared plus 1. So if we are given y equals ax squared plus bx plus c, we must be able to write it in that format. Okay, so I can actually show you example question 3 to sketch the graph of g of x equals minus 2x squared minus 5x plus 3. That is not giving me my P and Q. If it's not in the P and Q format, then I'm not going to be able to sketch it. So here's my P and Q, and P and Q are always my turning point. So I would like to find out what that information is. Now, grade 11s, you would have in algebra, you would have worked with this squared bracket that we are speaking about when you were dealing with quadratic equations. So my next job is to get a square bracket in here. And the way that I do that is by completing the square to get a square bracket. Because to get a square, I complete the square. So if I divide by negative 2, I'm going to get x squared plus 5 over 2x. And then I'm going to divide by negative 2, so I'm going to get minus 3 over 2. So there's my factorized form, because I can only complete the square when the coefficient of x squared is 1. So if I multiply negative 2 by that, I get back there. If I multiply by that value, I'm getting negative 5. And if I multiply by negative 3 over 2, I get plus 3. How do we complete the square? We take half of 5 over 2 and we square it. So I add on 25 over 16. But if we're completing the square just on one side and we're adding on a value, then I'm going to have enlarged that by that factor. So I want to actually take it away. So I add it in and I take it away. Let me just tidy this up here. So this is what I had. Minus 3 over 2. And I'm going to minus 25 over 16. So grade 11s, this is the additive inverse. Adding 25 minus 25 is 0, so I haven't affected the value. But what this has allowed me to do is to complete the square on the inside. So now I get an x plus a 5 over 4 squared. And that's times 8. So that's minus 24 minus 25. So that's minus 49 over 16. So I've been able to complete the square by just factorizing it first, because this expression was not ready for completing of the square. And then I'm going to multiply minus 2 into that first bracket there, and I'm going to multiply minus 2 by that value over here. So I'm going to get a plus. No, let's not do that. There we go. So that would be a plus 49 over 8. Now, look for that P and Q, grade 11s. The coefficient of the bracket, I haven't discussed it with you, but the coefficient of the bracket is the same as A, behaved like last year. It will stretch the graph or compress it, whereas my P is the value that you're adding to X, and Q is the value that you are raising the bracket by. So, do you agree that in this case, P is negative 5/4, because I've got a value. How do I zero this? Minus 5 plus 5 is 0. And my Q value is 49/8. So if I was sketching my parabola, I would know that at negative 5/4 I'm going to get, which is negative 4 1/4. So it's 1, 2, 3, 4. So it's negative 4 1/4. So it's about there. And then I'm going to go up to 49/8, which is just over 6 1/8. So it's going to go up there. 1, 2, 3, 4, 5, 6 1/8. So my turning point is actually going to be up there. And then this gives me the shape of the graph. I now know that my graph is going to have a maximum because my coefficient is negative. And I also know that it's going to go through about there. So, okay, it's not very well symmetrical because this distance here must be the same as that distance there. So I would need a bit more shape there. Okay, if we just do that a little bit better, then we now have my graph is going to turn at negative 4 1/4, negative 6/8. The shape tells me it's going to come down, and then I can work out what the x-intercepts are. Grade 11s, how would we work out where this cuts the y-axis? What kind of points are the green points? The green points are your x-intercepts, and we find those green values when our equation of the graph, which you can use as this equation, or which you can use as that equation, doesn't really matter, but as long as you're solving that equation, x plus 5/4 squared plus 49/8, and that's equal to 0. So you're solving for x like any quadratic equation, okay? And the beauty is, whatever format you use, you're solving a quadratic. And remember, in term 1, we solved quadratics, and now you can see the application of solving that quadratic. So that would be how you would sketch. You would find those, you'd find the y-intercept, and then you would draw in that axis of symmetry at x equals negative 4 1/4. Actually, 4 into 5 goes 1. It's not 4 1/4. It's actually, let's just pick that up. Let's just correct that. This x is negative 1 1/4. Okay, so that's just 1 1/4 units across. Because minus 5/4 is negative 1 1/4. Okay, so that's the parabola. Let's go and just discuss what the effects of P and Q would be on a hyperbola. I'm just going to briefly look at this. You agree, grade 11s, that you've seen this in grade 10 as the graph where the product of the factors is 6. So you would have sketched this graph. You would take in factors 1, 6, 2, 3, etc., and you would have a discontinuous graph, a discontinuous curve. You now are asked to investigate what would this graph look like if we're now taking the same knowledge as we've looked at with a parabola. What would x minus 2, what kind of translation would that x minus 2 affect? And exactly what we've said in the parabola is that the negative 2 will translate to the right, and what will be translated to the right? In this case, it's the asymptote. So my asymptote is now going to be at 2. So I've got an asymptote at 2, and the plus 1, like it did in the parabola, it's going to lift the graph by 1 unit. So my asymptote, which was this line, is now going to be at 1. And it's basically the green becomes my new axis for the graph. So that becomes my, no, that's not x, that's actually the y equals 1 line. So that's y equals 1, and this is the line x equals 2. So you can see that your asymptotes cross at that point 2, 1, and your new graph is now going to have translated that way, and it's going to have translated that way. And the nice thing is you can actually work out where it intersects the axis by just substituting x equals 0 and y equals 0 and finding out the intercepts. So anything you add to x is going to affect the horizontal translation. Anything you add to y, it's going to affect the vertical translation. So here, p is 2, therefore the asymptote is x equals 2. And why do we have a break now at 2? Because if I have 2 minus 2, I've got 0 in my denominator. That creates an undefined statement. So therefore 2 is my discontinuity line. And q is equal to 1. So my horizontal asymptote is y equals 1. Okay, so that's where the discontinuity is. If I had to rewrite this equation in this form, y minus 1, taking this over, multiplied by x minus 2 is equal to 6. Algebraically, we're saying that 1 minus 1 is 0, and if this factor was 0, then 0 times what would give me 6, and we would not find a factor over here. So therefore, the y can't be 1, and therefore my domain is affected, my range is affected, and my whole graph shifts across 2 and up 1, as well as your axis of symmetry. This axis of symmetry is now going to be y equals x, and it will be minus 1, because it's going to go across 2 and up 1, so it's going to go through that point. So if my gradient is 1, then I'm going to have to go through, if this is 2 and my y value is 1, then that would be minus 1. Okay. And this axis of symmetry going through there is the line y equals minus x plus c. So that would be plus 3. So the axis of symmetry also translate with it. This was my old origin. Those are my axis of symmetry for my new hyperbola. So P and Q have the same effect as they had for the parabola. They will translate the graph horizontally and vertically. However, they give us different information. PQ tells us the turning point in a parabola. PQ tells us the values of the asymptotes in the hyperbola. So even though they show us graphical translations, algebraically they're giving us different kind of information. Okay, so I think that's all we're going to look at this stage. We'll come back and do a question that revolves around looking at the summary of these two very important translations.
It's time for a break, so go get some water and grab a snack, and we'll be here when you get back. Welcome back, Mindsetters. Today we are doing revision. Even though we have selected highlights from previous shows, you can still follow me on Twitter at LearnExtra, or post or comment on Facebook on facebook.com/LearnExtra.
I want to first look at how to find the equations of two parabolas. Okay, so the first one is a parabola that's got a turning point of 2, 3, and it's got one other point, 3, 1. And the second one is an equation that's got an x-intercept of -6 and -2, and it's got this point here of -1, -10. And last week we looked at the equations of the parabola in a specific form, in the completed square form, and today we're going to go backwards. If we are given the turning point, how would we find the equation of the parabola? So first thing is to recognize that we are given the turning point, which means that we are given that PQ value, X of the axis of symmetry and Q the maximum or the minimum value. So we're given the turning point. If that happens, then I'm going to substitute the turning point into the equation y equals a into x minus p squared plus q. Okay? So if I'm given PQ, it means I must be able to substitute into PQ, but now I'm still missing that coefficient of x squared, that coefficient that stretches the graph. And in order to find it, I would need another xy. Can you see I've got another second point 3, that I can substitute in. So I'm going to do both those substitutions at the same time. So we're going to have the point 3, 1, y is 1, x is 3, p is 2, and q is 3. And we then have that 1 minus 3 is negative 2, so a is equal to negative 2. Since we have 3 minus 2 is 1, and 1 squared is just 1. So a is equal to negative 2. So I can now go into my equation and say that I've got y equals negative 2, and I now substitute my PQ as 2, 3. That's my PQ. X minus 2 squared plus 3. Okay. So that becomes the equation. If you would like to set that equation into the 3 terms, ax squared plus bx plus c, you'll just multiply it out. So you'll actually get minus 2 into x squared minus 4x plus 4 plus 3. And so that's the same as negative 2 into, let's just undo here. Okay, that's equal to negative 2x squared minus plus 8x minus 8 plus 3, which would be minus 5. Okay, so sometimes if the question starts off by saying find the equation in that form, it doesn't necessarily mean that you need to start with that form. You need to start with the form in terms of what information is actually being given. And since we've been given the turning point, we would begin with PQ, with the formula PQ. Now, notice that with this question here, I'm not given PQ. I can work out what P is, but I wouldn't know what Q is. So I would rather focus on that the given here is the x-intercept. So I'm given that x is negative 6 and x is negative 2, and then I'm given one more point. Now, there is another formula, and I just want to highlight this one here because it's the formula that you'll use if it's the turning point formula. So this is a turning point formula. I'm now going to write down the formula for, okay, that sounds a little bit odd, hey? So let's go formula for x-intercepts. And for the x-intercepts, you will say y equals a x minus the one x-intercept multiplied by x minus the second intercept. Okay? Where alpha is equal to negative 6 and beta is equal to negative 2. So alpha and beta are just your intercepts. So now I'm going to substitute in. So I get negative 10 is equal to a, x is negative 1, plus 6 multiplied by negative 1, plus 2, and I can now solve for a. So I'm really substituting a point here, and I'm also substituting negative 1, negative 10 at the same time. So I get negative 10 into 6 minus 1 is 5, and 2 minus 1 is 1. So that would just be 5. So therefore, a is equal to negative 2. So my equation of this parabola over here is y equals negative 2x plus 6 x plus 2. If you wanted in the three-termed version, then you would just multiply those brackets out. So you'd get x squared plus 8x plus 12. And that would be negative 2x squared minus 16x minus 24. That would be that equation. And we can just split this over here. So the equation into the ax squared plus bx plus c format. Okay, so that's just going backwards. And the parabola is one of those functions that has two ways of being able to be calculated. So you need to first identify, what am I given? Turning point or x-intercepts? Okay. Right, then I want to do a little introduction, just a very brief introduction. We're not going to get through all the questions. We're going to do some of the more important ones. If f of x is equal to 2x squared minus 12x and y is equal to ax plus q, and the two graphs are intersecting, you'll notice later on we've got this graph over here. So the graphs are intersecting at the origin and they're intersecting at C. D is the turning point. B and O are the x-intercepts, and let's go and see if there's anything else interesting. D is the turning point of the, and D is parallel to x-axis, and CF is parallel to the y-axis with F on the x-axis. Okay, so let's just chat about the coordinates of B. What is B and how would we work its coordinates out? Okay, so B is this little x-intercept here, and how would we work out the coordinates? If it's the x-intercept of the parabola, we'll go to the parabola, which has been given to us as 2x squared plus 2x, and we can certainly work out what the coordinates of B are. So it's really here, our 2x squared minus 12x is equal to 0. So therefore, if we take out x, we're left with 2x minus 6 is equal to 0. So we get x is 0 or x is equal to 3. So those are our x-intercepts. The coordinates of D. Okay, grade 11s. D. D is the turning point. How would you calculate the coordinates of the turning point of a parabola? Well, we spoke about last week that P and Q give us the give us that turning point. Therefore, you would need to complete the square. However, if you do complete the square on y equals ax squared plus bx plus c, you actually get the formula for the x of the turning point or the axis of symmetry. So I'm actually just going to do that. Our x of the turning point is going to be always minus b over 2a. And our equation for our parabola is f of x equals 2x squared minus 12x. So if I look at what b is and I go and get it from the formula, that would be just a 12. And 2a would be 2 times what a is. So 12 over 4 would be equal to 3. We had that the x-intercept here should have been 6. So when we come to our graph and we actually fill in that this value here is 6, then we can see that if this distance is 6, that this yellow line will bisect that distance. So that value there must be 3. Hence the x of the turning point being the 3. And what do we do to get the y value? We would substitute 3 back in there. So 3 times 3 is 9, times 2 is 18. 18 minus 36 would be negative 18. So this value over here is 3. And then just double check here. F of 3 would be 2 times 3 squared minus 12 times 3. So that's 18 minus 36, which is negative 18. So that's the coordinates of D, which means this horizontal line is the line y equals negative 18. So that's calculating intercepts, turning point. I'm sure the values of A and Q, the gradient and the y-intercept, the length of CD, the coordinates of C, if CF is 10. I like this question. What are the coordinates of C if CF is 10? Let's go and see where CF is. CF is this line here. So they're telling us that this distance is 10 units. How would we set up an equation to determine what OF is, or what are the coordinates of F? I think the question was the coordinates of C. So what are the coordinates of C if this is 10 units? So we know that the y value is 10, but what is the coordinate? What is the y coordinate of C if I'm coming down into this quadrant? My y value in this quadrant is negative. So they've given me the distance as positive, but the coordinate is actually negative. And it simply means that if I've got to get the x value of the coordinate, then I would need to equate minus 10 to 2x squared minus 12x. And that would mean I would get a x squared, if I divide by 2, minus a 6x. This is a plus 10 plus 5 is equal to 0. So I get an x plus 5, or rather an x minus 5. So that's an x minus 5 times an x minus 1. And that gives us an x value on this side of 5, because there must be an x value of 1 on this side. That's also negative 10. So that would be a 5. Okay. So that would be the coordinates of that value, C. And then I would like to look at what are the values of x for which f is smaller than g. Where would you read that, grade 11s? It's a very famous question, and what people often do is they take the algebraic functions and they equate them to each other. Now, there are alternatives in solving for x in this case. Yes, you can do it algebraically, but you're setting up a quadratic inequality. The graph actually really helps us to find where f is smaller than g. Now, f is our parabola, so I like to put some colloquial language to what this is saying. This is saying, where is y of the parabola, just the y values, smaller than or equal to the y value of the straight line? So if we now begin to talk about the function values of those specific graphs, can you see we're now focusing our attention on the actual values here? So let's go to, there's my function g, there's f, and I'm going to ask you, where do you see that y is smaller? Now, I see lots of y's, lots of x's. The best way to deal with this is to put your ruler to the extreme left of the turning point. So do you agree that these graphs will be equal at the origin and at this point C? That's where they will be the same. But the moment I move to the right, at this x value, which could be 1, at 1, this y value over here is a lot larger than that value over there. And if I keep moving across to 3, that value there is much larger than that value. And if I keep moving, I tend towards where they are equal. So between these two blue points, the y on the straight line is larger than the y on the parabola. So you actually take a vertical value, which represents your x, and you at that point decide who is bigger. The straight line in terms of the y values, the y of the straight or the y of the parabola. You keep moving until they meet. Now can you see if I move to the left and I choose a value over here, okay, my y of the parabola is much larger than my y of the straight line. I don't have to mark every single angle. I can see that as I move up and up, that's going off to infinity. So my y of the parabola keeps increasing as I move that way. So there's also a change that happens to the right. Here, if I take a value there, my y of the parabola is much larger than the y of the straight line. So with one simple movement with your ruler, if you take your ruler on your graph, you move left, you move right, what's happening to the y values? You move left, you move right, what's happening to your y values? I can tell you that my parabola is larger, so I'm going to find this solution here. This is found where? And when I say where, I'm talking about what is happening to x. So find x so that that's happening. Can you see x for my parabola? Oh, it's actually my parabola is going to be smaller, hey? Not bigger than. So my parabola is smaller in this region of points here. from the 0x to the 5, it will happen. So I can actually say that x then is between 5 and 0. So this is my given. This is where you go to find the fixed given information on your function values. The moment you've got your function values, you can now go and find out what's happening to x. I'm sure you'll be able to find where is f positive. Try and put some colloquial language to it, or some mathematical colloquial language to it. That means, where is y of my parabola? Where is it positive? And where do I find my y's positive? Whenever they are above the y-axis. So that's given. You tell me what is happening to x. Where is it found? Where are those pink arrows indicating the x values? They are indicating x values smaller than 0 and bigger than 6. So put some understanding to that language. And what is this one saying? Where is the product of, okay, so product, so I need to multiply them, of my y of my parabola multiplied by y of my straight line. Where is the product of those two y values? Less than 0 means negative. Okay, well, again, you use your ruler. Use your ruler, use a vertical piece of paper. What is happening to the left of 0? If I multiply those two values together, they're both positive, they're both positive, they're both positive. So they keep staying positive. Okay, the moment I move to the right of 0, at these values over here, I've got a negative and a negative. So if I times those two negatives, I get a positive, negative, 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 negative. What happens now? If I move to the right of 6, I'm going to get a positive multiplied by a negative is going to give me a negative. So values over here are positive, values over here are positive, and they change whenever one of them crosses the axis, which happened at 6. So the product is only going to be negative to the right of 6, because everywhere else, if I take any two values on the graph, I'm getting a positive product. So you literally use your fingers to indicate where those products are positive and negative. Okay, so that is more of the sort of real nitty-gritty of two functions, the straight line there and the parabola, to work out where are the two graphs bigger or smaller, and we always look at it in terms of their vertical values. So in terms of their y values, you need to then go and read what's happening with the x. Where is the one positive and where is the product positive? We can ask you where is the quotient negative. All those things can be asked around the interpretation of graphs. Okay, so here's a question. The graphs of the following functions are given. F of x is negative x squared plus 9. And we need to find the average gradient of the curve between the points where x is 1 and x is 5. Okay, so we have a parabola. It is a curve. It doesn't have a constant gradient. All right? So let's go and see where x is 1 and where x is 5. I think that's what they asked us for. Yes. X is 1 and x is 5. What we're now saying is that if I had to take that gradient, there would be a line, there would be a secant. Okay? And the average gradient is the gradient of this line. Average gradient is equal to my y value over here is negative 14 minus my y value over here is 8. And I'm dividing it by the change in x, that's 5, minus this x value, which is 1. So that gradient is negative 22 over 4. So that gradient is negative 11 over 2. So it's negative 5.5. So we are saying that that curve has approximately that gradient. But if I had to choose two other points, it would no longer be 5.5, it would be something else. So just between those 2 points, there exists a secant. So the average gradient, let's just do this right. this in a better way. So the average gradient, okay, is the gradient of the secant on a curve. It will always be on a curve. It will never exist on a straight line graph. Okay. And just as an add-on, for which values of x will f of x be increasing and where will it be decreasing? What is the definition of increasing? Something's got to be fixed, grade 11s. You've always got to look at that. My x, what happens as x gets larger? Then my function value also. It's what is happening with the one value in relation to another value. As x increases, y also increases. Where is that happening on the parabola? And what is the definition of decreasing? As x gets bigger, as you move along in your set of x values, my y value decreases. So there's a difference in the relationship where that relationship is the same. So if we look at our function, can you see that as I move from -4 to -3 to -2 to -1, my y value increases. But the moment it turns, after it's turned, as my x increases, I'm getting bigger x's, my y is getting smaller. So up to this point, from this value to that value there, my function will decrease. So no, it's not decreasing, it's increasing because it's getting bigger. So let's just write it in that function increases because my y's are getting larger. But on that side, my y's are getting smaller, so my function decreases. Okay, right. Let's just see if we can do one more of those. Okay. So the diagram represents the graph of y equals x squared minus y equals x squared minus 2x. Okay. And we'd like to determine the coordinates of those points so that we can work out what is the average gradient between A and B, between A and C, between A and D. So if we go back and work out what the coordinates are and just say that this is 4, so this point is 4 and that is 8, and C is the point 3, 3, and D is 2, 0, E, and then A is the point 1, -1, then if I work out the average gradient of AB, I'm working out this gradient there. Then I would like to work out this gradient over here. Then I would like to work out this gradient over there. And what is the difference between those gradients? A and B, let's just work out AB. So the gradient, let's work out this in yellow because we're working with this one. So the gradient of AB would be 8 plus 1 is 9 over 4 minus 1 is 3. So the gradient is 3. Of the pink one, we've got the gradient of AC. That would be 3 plus 1 is 4 all over 3 minus 1 is 2. So the gradient is 2. And then the green one, the gradient of AD would be 2 plus 1 is 3 over 0 minus 1 is -1. So that is, or actually should I say 0 plus 1 is 1. Okay, we're just rushing this a little bit here. So let's just fix that. So it would be a 0 plus 1 is 1 over 2 minus 1 is 1. So the gradient is 1. So we can see, even from the slope of those lines, that the gradient is getting smaller and smaller. And can you tell me what is happening at the grade, at A? What is happening to that gradient? So it's an interesting development to just look at how those gradients change between different points on the parabola.
We've come to the end of today's show. Thanks for joining me and for chatting to me during the show. Remember to visit our website learn.mindset.co.za to download the show notes and to watch all the videos from this year's shows. Goodbye.